Hello everyone, my name is Seth. I've been programming in Python for about 4 years now, and over the course of the last year, I realized a few things that I thought were really cool about Python dictionaries, and honestly, I kind of wish I knew about them earlier in my Python career. So I put together this Colab notebook here and making this video to share them with you. So if you're learning Python, hopefully this helps out and hopefully you can kind of realize some cool things about dictionaries and help make your code better. So let's start off with what a dictionary is. If you're not familiar with a dictionary, it's an associative array or a hash map. And what that means is, so like a list in Python is like an array, right? Where you have all these different values of things put into different indexes, right? But in a dictionary or an associative array, we're associating our values with a key. It's a key value pair. And that key is going to be hashed to find the memory address of your value, right? So I've got the Python hash function here. It's going to hash a bunch of different strings, cat, and cat with two A's. So we're going to see how when I run this, just changing one A completely changes the memory address. The other strings, even though they're different objects, it's the same string which goes into the function, same input, comes out with the same output, but changing it slightly gives it a completely different output. So you can think of these numeric values as the memory addresses. So by giving it a key, instead of having to search the whole list for a key and then getting the value out of it, it just hashes it and it knows, okay, just jump right to that address. So in that way, dictionaries can run in O of 1, which is pretty much as fast as you can get, which is awesome. I've heard people can kind of cheat some leak code challenges using dictionaries like that. I've not really experienced that myself, but I just threw this in here as a little example here of kind of flexibility and usability of dictionaries. It has pretty much the exact same syntax as JSON. If you're not familiar with JSON, it is a really common way of organizing data and sending it across the web. But yeah, like I just Googled JSON example, copied and pasted it straight in here, and Python's treating it as if it's a dictionary, right? And the important thing I think to note here is you can just tag on all these different retrieval methods using your brackets to get deep into the nested aspect of this JSON example dictionary here. If it runs, it had to go pretty deep. So yeah, here's OpenDoc. So yeah, that's, like I said, just really quick introduction on dictionaries. If you want to learn more about dictionaries or get more background on them, I suggest this Dataquest article. I have no affiliation with Dataquest or the author of that article. I just found it to be super helpful and super useful when I was researching this and putting it together. So yeah, let's jump into the cool stuff. The first of the two big epiphanies here. Using dictionaries as a priority queue. So if you're not familiar with what a priority queue is, it's just like a normal queue. And by queue, I mean, it's like a line, right? You're in line for your burgers. You're at the end of the line. You go all the way through the line, and then you order your burger, and then you pop out a line, right? Priority queue is a little bit different than that. You get added to the line, and you get assigned a priority. It's more like a hospital, right? Let's say I broke my wrist, so that's an emergency. I'm going to the hospital. They're going to be like, all right, yeah, that's an emergency, but that's like a 3. This other guy, he got shot, dude. He's like a 1. Like you're going to wait for a minute here. So that's kind of the concept behind a priority queue. So we can organize priorities. Like I said, like a 1 is, in my mind, the highest priority. And like a 3 would be the third highest priority, right? So there's a function called min. A lot of people are already familiar with it, and it'll pull the minimum out of an iterable that you pass it, right? There's also maximum. If you want to flip it around, it'll pull the 6 out instead of the 1. But what I didn't realize until more recently is the min has these two optional arguments here. You can give it this key argument, and the word key is going to be used in several different contexts, like juxtapositioned here, so it might get a little confusing, so sorry about that, but I'll try to keep it as clear as I can. So this key parameter provides a key function that each thing in this iterable is going to get passed to that function, and then min is going to it's going to return the minimum of what's returned from that function. All right, so let's look at an example here. So I've got a dictionary, calling it Q. I've got our keys. Again, this is the dictionary key of the key value as 1, 2, and 3. I've got 6, 5, and 4. And the reason I'm putting these numbers here is so we can see that when I call min directly on the dictionary, it's going to pull out the smallest numeric key. Okay? But if we use the key argument and pass it the function get, and if you're not familiar with get, it's just a cleaner way of using that bracket syntax to get the value that's associated with the dictionary key that you pass it. So these two function calls will do the same thing here. I'm passing it a key in a lambda, or I'm just calling get, and it's going to pass each key to that key function. I warned you about that, those context of key, so sorry about that. But min is essentially going to resolve the minimum of get, which is going to be the value. So I realized that could be a little bit like, whoa, what is he talking about? He said key like a million times, and he's got like a bunch of different numbers like here. So let's look at the results here, right? So if you call minimum on the dictionary itself, it returns the smallest key, which is 1. If you use the key argument, it's going to return the smallest value, C4, right? And that is 3. So it might be a little bit easier to understand here, at least at my mind, if we add some strings in the mix to separate these numbers out a little bit. So similar to above, I've got 1, 2, and 3, dogs, cats, and birds. And then I switched it around, right? So dogs, let's say we've got dogs as a priority 6, cats is 4, birds is also 4. And here's a cool part, right? If we have our numeric values as our keys of the dictionary, they have to be unique, because remember, if you have two keys that are the same, those values are going to collide in your hash. Like they're going to conflict. They're going to be at the same memory address. And Python's like, no, we can't do that. So your keys have to be unique. So we can give two different objects or two different strings the same priority code if we put the codes as the values instead. So this is already kind of something that like I've never really thought about at first in my earlier stages of Python coding. I always thought of keys as like the nickname of the dictionary that I'm just going to go grab the thing that I actually care about. But here, it's almost like, well, we kind of care about both, but you want to grab the lowest priority or the highest priority, lowest number, and get me back cats is what I care about, right? I don't care about 4. I care about cats. And we're doing that we're actually pulling out dogs in this first example because we have to go back and find the selected key. Because remember, it's going to return 1, and then we're going to go give me P of 1, or 1 from P. Whereas if we use the key parameter and the get function in min, we'll just get it all in one action. There we go, we got cats. Note that, oh man, really? I'm disconnecting things? All right, looks like I'm back, cool. Note that birds and cats have the same priority. It's going to return the first lowest value that it finds, right? So if they're duplicates, it returns the first. And dictionaries used to not guarantee order, but I don't remember the exact version of Python, but since that version, it does guarantee this is going to be the same every time when you print it. So it's always going to be cats in this scenario until you remove cats, and we'll talk about that in a minute here. So yeah, the point I want to take out of that one is switching the position of what you care about, taking it out of the value and putting it in the dictionary key, right? So we can actually, instead of using strings, we can put objects. I'm going to zoom out a little bit here so you can see this whole code block. That didn't really help. I mean, maybe it helped a little bit. But yeah, so I got a cat class here. I made a bunch of cats instances, and each one of these is going to have its own unique memory address. So we can use them as keys in our cat queue here. We've got tabbies is 3, calicos is 3, tuxedos is second only to black cats because black cats are the best cats. Torties are 4 because obviously I'm not a fan of torties, but if you're a fan of torties, please, no offense. Black cats are the best cats. So yeah, we're going to adopt a cat out of our cat queue. And all in one step, we don't got to go back and find like, oh, give me the cat that was with 1. It's going to pull out the minimum, which is our highest priority, using the get function out of the cat queue. Give it the adopted cat, and the adopted has a color, and it can meow and it can purr right then and there. Got a lot of cats to check. See, there we go. We got a black cat, it can meow and purr. But an important thing to note, so like we've got our priority aspect down. We've changed our dictionary, or our concept of thinking of a dictionary, so we can keep the important thing that we care about as the keys, and overlapping priority codes as the values. So we've got that part of the priority queue down, but it's not a true queue yet because cats, or the black cat's still in the priority queue, which shouldn't be, right? Like we adopted the cat. He's not at the shelter anymore. So let's see how we can do that. We can use the del keyword here. Now del, quick note, it'll work on pretty much anything in Python, or anything that has a memory address. It'll just remove it from memory. So it's not dictionary specific, but if we use del, so we selected our priority, I guess it was birds. Yeah, it was birds in this scenario because birds is 4. That's the lowest number. And then we can move selected from the dictionary, right? Birds is no longer there. So these are kind of like two similar actions, or they're two important aspects of a priority queue that are kind of like separate, kind of hang out in the open. We can encapsulate that, but first I want to talk about some different methods, some different options here. You might have heard about pop. Pop is kind of concept that's more associated with stacks, and that does exactly what we just did here. It selects something and then deletes it from that collection and returns it for you. But pop doesn't really work. I mean, it does that, but it doesn't work the way we want it to in our priority queue here, because pop, what does pop do? Pop will return the value. It's going to return 4 instead of birds, but we already established we care about birds. We don't care about 4. If this ever runs, you'll see that. Hey, there it is. Yeah, see, it returned 4. But remember, the reason we're putting the thing we care about as the key is so we can have the same priority for 2 different things, right? So if we change cats to 4, it'll return 4 still, but it'll remove cats out of the queue. Hello? I think my computer's been awake for too long. There we go. Yeah, see, birds is still in there, cats is gone, but we got 4, but we don't want 4, we want cats. So pop item returns both the key and the value, but the thing about pop item that's not useful for us is it only returns the last thing in the dictionary. Remember how I mentioned nowadays Python dictionaries do have an order? If you give this an argument, it'll just throw an error because it doesn't accept arguments. So there's no way of saying like, give me a priority, you know? Even if you put this in the minimum function, right? Let's say we want the minimum to be pop item. Pop item. That's not going to work because the way that key function works is it passes each of these iterables to pop item, right? And it doesn't accept an argument. So and do that, rerun that so we don't got any errors. So we've got our min function with get. We're deleting out of the queue, and we can wrap it all together and return it in a dequeue method. Dequeue is the queue version of pop, right? So that's a way around that. See, we've got birds. Birds was a 4. Birds is no longer in the dictionary. And that was just from one call to dequeue. But our dictionary queue and our dequeue method are still kind of out in the open, like separated. They're related, but they're not together. In some scenarios, this might be good. This might work perfectly fine for you. It's worked perfectly fine for me in the past. But in other scenarios, you might want to package them together in a small little class here. So we made a priority queue class. It's really simple. It just has a simple data structure, dictionary. It has an enqueue method that uses dictionary update function, so we can add things to it. So now it's a real priority queue, because you need to be able to add things to your queue. You can't just start and just remove, right? And then we've got that dequeue function we just made. And I made a little wrapper function for items, because we can't print directly like we were before, just printing the queue. It'll print the priority queue's just memory address because it's object now. So that items wrapper function just returns the dictionary items method, so we can see that birds actually was removed from our queue. So yeah, that pretty much wraps up what I wanted to talk about with priority queues in Python dictionaries. I hope that was helpful. I think the key things to take home here are kind of switching your perspective of not only being restricted to storing the thing that you care about as the value in a dictionary and using the key as just a nickname to go get that thing, where you can really switch it around and reverse it. And the thing that we can care about, as long as it's unique, can be the key itself. And then we can use this min function with this special key argument to go get priority codes that may be overlapping, right? Like, let's say 3 people broke their wrists and 2 people got shot, right? That doesn't matter, because they'll have the 2 different people or 2 unique people as the keys in our dictionary. And their priority codes can be the values, and they don't have to be unique. There are priority queues out there. Somebody's already implemented them stuff in different libraries. But sometimes you don't want to depend on someone else's code. Sometimes you don't want to bother with imports, right? In some scenarios, it's nice to make a little lightweight class like this just in Python itself, right? So you're not relying on somebody else, like no dependencies. So that's another cool thing about this. All right, this part's really cool. This is the part where I woke up in the end of last summer and was like, oh my God, you can store functions in dictionaries. Why did I not know about this before? And I immediately just grabbed my laptop and started making this Colab notebook here. So yeah, this is what I'm really stoked to share with you guys. So here we go. We've got a couple functions here: make lemonade, make apple cider. And yeah, that's what I learned through the ages, how to make these 2 beverages. So I'm storing these recipes here, these functions that are these recipes in a dictionary called recipes. And I'm going to use the keys. I'm going to use the names of the fruits that we would associate with these recipes as the keys. All right, so we can get the recipe. I could actually do is print, let's assign this. What do we do with apples? Cider. So let's print cider. Hey, stop it. So there we go. We're going to print our recipe, So a recipe doesn't really do much good if it's just, we can get it out of our recipe book, right? But we want to make a drink, right? So we got to execute the recipe. So you can throw some parentheses on the end of that dictionary retrieval call, and it just executes it right then and there, which is pretty cool. I didn't always know about that. Once I discovered that, I was like, this is why haven't I been utilizing this? This can be pretty powerful, right? We don't have grapes in our recipe, or any recipe for grapes yet in our book. So it's going to throw a key error. Maybe. Jeez. This is what happens when you make your videos during peak internet hours. Hey, there we go. Key error for grapes. So to avoid that, we can use that get function, right? It doesn't just look cleaner like when we were using it for our priority queue. It actually acts cleaner too. Instead of throwing an error, it just returns none if grapes isn't in our recipes dictionary, right? And another cool thing about get is that you can actually give it a default. Instead of none, it'll return this make wine that I just told it to, that I just made here. But if this ever runs, there we go. You can see it doesn't add it to the dictionary. So we know that there's a recipe out there for grapes, but we can't really remember it because it's not in our recipes book. Now, this is a really cool thing that I didn't know until recently. You can switch your get method out with a set default, and this will add it. This will add it to the dictionary if it's not in there, right? So it wasn't in there. We're like, let's make a recipe for grapes. If it's not in there, return our wine recipe and then execute it. And that's what it did. And this is just kind of a combination of the two different methods I was showing earlier. You can separate this out here just for explanity's sake. Let's do the same thing. See, we're just going to return it and then call it, instead of the way I had it before. I was just calling it in one step. Right. Okay, so grapes is in our dictionary now. We've got lemons and we've got apples. So we can package all those known keys, our known fruits, into a list. And then we can use the same quick little call to make each recipe in a for loop, right? So hopefully now we're starting to see how the kind of flexibility is starting to really show itself, right? Like, get this fruit, get that fruit, get the other fruit, and give me all the recipes, make the recipes. All right, up until now, it's just an empty set of parentheses on the end. What if we have parameters for our function that we want to store? Easy, just add them to the parentheses. It's the same as calling a function. It is calling the function, right? So I've got our two greetings here. We've got a formal and an informal. And we can pass them different names as we get them out of the dictionary, right? And we're doing that two different ways, using the bracket syntax, using the get syntax. Hello, Alice. And then to take things even a step further, we can wrap them in a lambda function and make it really nice and neat, right? So this is, all it's doing is it's getting a formality, a function associated with a formality out of our greetings dictionary, and passing a name to that function and executing it immediately. All right, so now it just looks like a function now, but really at the core of it, it's a dictionary call. We're just getting something out of a dictionary, but it's acting like a function, like a really flexible function, because I can tell it, give me a formal for Alice and give me an informal for Bob. And now I don't have like defined like def, greet, if formal, blah, 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 if informal, blah, blah, blah. right? It's just pulling it straight out of the dictionary. So it's a lot cleaner. And here's where it gets really cool. We can combine our fruit dictionary and our greetings dictionary into a super clean little greetings with fruit method, right? Just think of how big that if else chain would go on if we wanted to combine those two with like all these different scenarios. Let's say it's formal, let's say it's informal, let's say it's formal and it's an apple, let's say it's formal and it's a lemon, let's say it's informal and it's grapes. What if we had like 70 fruits, right? This is all just like right here, nice and clean and compact. So you can really see how like it can kill these if elif chains and just clean up your code really well. So yeah, hopefully that shows you some awesome, cool things that you can do with dictionaries and functions in Python and really just kind of unlock the power of them. Like I said, this isn't something that I always knew about. I kind of wish I knew about it earlier. That's why I wanted to share it. And yeah, I hope now that you can go on and clean up some code and continue to develop Python. So thank you for watching.